All right, geometry peeps, here we are back at it again. I'm going to go ahead and I'm going to title today's lesson Mixed Practice. So up at the top of the page, go ahead and write Mixed Practice. And I'm once again here with my puppy Rosie and my kitty cat Tipsy. They're going to help me along this journey. So let's go ahead and let's get started. I'm going to go ahead and start with example 1. And these are going to be fairly straightforward and not as much writing as the word problems that we did in the last video. So I'm going to go ahead and start with this right triangle. I'm going to make my hypotenuse x. This angle down in the bottom right hand corner 57 degrees. And the bottom piece of that triangle 7. And of course I know that I'm solving for x. So in order to do this, I'm going to remember my 3 trig ratios, my SOHCAHTOA, or my some old horse, caught another horse, taking oats away. And like I did before, I'm going to go label the parts of my triangle. So across from the right angle, that's my hypotenuse. Across from my 57, that's my opposite. Which makes this bottom side my adjacent. So it looks like I've got a hypotenuse and adjacent, nothing going on over there with opposite. So I need to use the trig ratio that deals with hypotenuse and adjacent. So not that one, not that one. Cosine is hypotenuse and adjacent. So this is a cosine problem. So cosine of 57 degrees is equal to the adjacent side 7 over the hypotenuse x. Cosine of 57 degrees I can type into the calculator, so I'm going to do it. So I'm going to go ahead and get my calculator out. You should go ahead and type this right in right along with me. Let me go grab my calculator and type in cosine of 57 degrees. Remember, we're always going to put 4 decimal places down on our paper. So the first 4 that you see, 0.5446 equals 7 over x. And now I'm all set to go ahead and cross multiply. And to solve for x, I can divide both sides by that 0.5446 number. And remember that when you enter this into the calculator, you have to use the whole decimal display. So you're going to have to do some copying and pasting. You can't use just the 4 decimals. And in this video, we're going to round each of these to the nearest tenth, so 12.9. Beautiful. Tipsy and Rosie say good job. Let's go try another one. I'm going to call this one example 2. Once again, I'm going to start with a right triangle, but I think just to be different, I'm going to draw this one backwards. I'm going to make this 27 degrees. This is x, 17. So again, I'm working with my SOHCAHTOA. So once again, I've got my 3 trig functions. Some old horse, caught another horse, taking oats away, or SOHCAHTOA. I've got 17, which is my hypotenuse. The side opposite that 27-degree angle is x, making this bottom piece the adjacent. So it looks like in this question, I've got the hypotenuse and the adjacent. Sorry, the hypotenuse in the opposite. So I like the sine function for this question. This is a sine problem. So sine of my 27-degree angle is equal to the side opposite, which is x, over the hypotenuse, which is 17. So into my calculator goes sine of 27, or 0.4539, equals the x over the 17. So when I cross multiply, x is equal to the 17 times the 0.4539 number. Or to the nearest tenth, 7.7. At this point, when I go on to my example 3, I'm going to go up to the top of the next page, but you can feel free to keep working right on the same page as long as you have room. So example 3, you guessed it, I'm going to start once again with a right triangle. And in this right triangle, my two legs measure 15 and 17. And what I want to find in this problem is I want to find x, which is an angle. So I'm looking for the measure of angle x. I've got my so-ka-toa, my some old horse, caught another horse, taking oats away. So I'm going to start by labeling my hypotenuse. My opposite is going to be across from angle x, so in this case my opposite is going to be the 15, making 17 my adjacent. So if I take a look at what I've got here, I've got the opposite and the adjacent. I need to use the trig ratio that deals with opposite and adjacent. Therefore, this is a tangent problem. So I've got tangent of angle x equals my opposite piece, which is 15, over my adjacent piece, which is 17. I can't plug tangent of angle x into the calculator. So what that tells me is that I'm going to have to use inverse trig. So I'm going to use inverse tangent on the left side. And if I use inverse tangent on the left side, I of course need to use inverse tangent on the right side. So inverse tangent and tangent cancel each other out, and I'm left with an x. And x is going to be equal to the inverse tangent of 15 over 17. So just be careful when you go in here. This time we want the inverse tangent. And to the nearest tenth, that angle's 41.4 degrees. Beautiful. We've got one more example to take a look at here. Rosie says, you're doing good. Keep up the great work. We're almost to the end. Once again, we're going to start with a right triangle. This time I'm going to make the hypotenuse of that right triangle 25 and this bottom piece 12. And we're going to be looking for, like in the last example, an angle. So I've got my some old horse caught another horse taking oats away, or my so ka toa. When I look at this problem, looks like my hypotenuse is 25. Looks like my opposite is 12. Making my adjacent this left side of my triangle. So I've got hypotenuse and opposite. I need to do the trig ratio that deals with opposite and hypotenuse. I'm liking the sine trig ratio for this problem. So this is a sine question. So sine of angle x equals 12 over 25. And when I go to try to put sine of angle x into the calculator, I can't do it. And what that tells me, since I can't put sine of angle x in the calculator, I'm going to have to use inverse trig. So I'm going to take inverse sine on the left side. And if I take inverse sine on the left side, I of course have to take inverse sine on the right side. So on the left side, I'm left with x. On the right side, I've got inverse sine of 12 over 25. And again, I'm just going to be very careful when I go to plug this into the calculator. The sine and the sine inverse look very, very, very similar. I want inverse sine of 12 over 25. So about 28.7 degrees. So there's a nice little recap of using trig to find sides and using trig to find angles. Once again, we've got a Castle learning assignment for you to do. And of course, remember that if you're struggling, if you're having trouble, reach out. I know Miss Andre misses you as much as I do. Feel free to get in touch with either one of us. We would love to Zoom with you. We can connect through Teams, email, but we've got lots of ways to support you if you're feeling like you're struggling with the trig. So the Castle learning assignment is going to be number 7, and it's called Mixed Practice. Rosie and Tipsy, of course, say great job on the mixed practice, folks. Till the next time, stay safe, stay healthy, take good care of your loved ones, and stay 6 feet apart.